So that's how you build a chatbot which can, read from external documents. The external documents can be PDF, it can be text, right? It can understand some external documents, and you can then build a Q&A system, question answer system based on those documents. You can upload, let's say, 10 or 1000, tens or thousands of research papers or PDFs, right? Or let's say your textbooks. Then you can create a chatbot around it. Hey everyone, welcome back to the channel. So in today's video, we are going to discuss four or five, I think, five more concepts of LangChain framework. So in our previous section, we discussed about structured output, multimodality, runnable interface, and streaming. So now we are going to discuss about document loaders, retrieval, text splitters, embedding models, vector stores, and retriever. Okay, so this 5 to 6 components we are going to discuss. Okay, with coding obviously, so that you'll get to understand about it in detail. Okay, so first we'll discuss about document loaders. So as the name suggests, document loaders is used to load some document, and document can be of anything, right? It can be a PDF, it can be a plain text file, it can be a JSON, it can be HTML, it can be a code file, Python code, anything. It can be anything. So using document loaders, you basically load the documents, okay, into the memory. Then if we see here, there are a lot of different type of techniques available to load different type of documents. Okay, you can load CSV data also, web pages also, right? Then JSON data, lot of data types are available which for you to load. Okay, so in our example, what we have done, let me just import my key first. Okay, then we are importing the text loader. Okay, because we'll be playing with a text file. We have a sample text file. I'll show you this. Okay, we have some information about AI here. Okay, some short history. So because the file is text file, that's why we are importing the text loader package. Okay, so if you want to load any other type of files, there are obviously options to load PDFs also. You can go with PDFs, but for the simplicity and for an easier understanding, I'm going with the text file for now. Okay, so what I've done here, we have just used a text loader to load the document, and if I run this, you get to see that content of this. Okay, the content of this has been uh, converted into a document object. Okay, this is a document class that is available in LangChain, and so it has been converted like this. Okay, so it has added some metadata also. Source is the sample text, the name of the file, and the base content, and the content of the sample.txt file has been added here as a document. Okay, so that was about a document loader. It enables you to load documents from different types of files. So the exciting thing here is when you load from a PDF. Now PDF can contain multiple types of thing, right? It can contain images, it can contain tables also, plain text also. So that's where the PDF rendering and loading PDFs becomes very tricky and very interesting also. If you see here, when you load a PDF, what it will do, it will the package that you will use, right, to load the PDF, maybe a PyPDF loader package is there. You can use that to load documents in your LLM application. So it is quite smart enough to detect the tables, then sections of the paragraph, right? It is smart enough to detect the section, then convert it to a text data. Okay, like this. Okay, if you see, the table has been converted like this. Table 1, current layout detection model in layout parser. If you see, current layout detection models in layout parser model zoo. Okay, then that the columns are the database model, large model, nodes, etc. So dataset, base model, large model, nodes, etc. So that's how document loaders work. It helps you convert the file data or content of any type of files into documents like this. Okay. Next thing is, the next concept is the text splitter. Okay. Now why do we need text splitter? See, before understanding why do we need text splitting, first let's just understand what is text splitting. So what text splitting does is, it converts the big document. Now in our case we have a smaller document here, right? But if the document size is too big, let's say it has pages of content in it, so in that case it becomes sensible enough to divide the document into smaller chunks, right? We call it as splits. Now the splits can be done in multiple ways based on the length of the number of words, based on the number of characters, based on the number of sentences, based on the type of data. Okay, there are multiple ways to split a big document into a smaller set of chunks or splits. Okay, Now the reason for splitting documents are given here. For example, handling non-uniform document lengths. For example, as I told, in this case the document length is small. I mean, we have very limited content. But if there will be another document which has a large number of content, a large amount of content in it, then dividing it to splits makes sense, because splitting the document into smaller chunks or smaller manageable chunks makes it easier for storage, right? Finally, when we have different type of documents, we have to store it in a vector database. I'll be discussing about vector database in a while. So it helps storing a big file into smaller chunks in a vector database, so that information retrieval becomes easier. Okay, information retrieval as in when user asks some question, you might want to search some relevant information from that document, right? So the document can be a book also. You are not going to pass the entire book content as the content to the as the context to the LLM, because that will be very lengthy. So that's why what we want to do, we want to fetch relevant information from the book to answer to the user query, then pass that relevant information along with the query as the context to the LLM, then LLM will be able to answer that question. So that is why we split the documents. Okay. um, so there are some advantages that is given. Overcoming model limitations. um, as you told, many embedding models, language models have maximum input size constraints, right? So splitting allows us to process documents that would otherwise exceed those limits, right? I mean, when we have big documents, splitting into smaller chunks makes it easier to convert it into embeddings, vector embeddings. I'm going to discuss about it, don't worry. Then store it in the vector database. Okay. So improving representation quality. Okay. Then enhancing the retrieval precision. That this is what I was talking about. Retrieving relevant or relevant information for a given user query becomes easier in this way. Okay. Then there are different type of approaches to split a big document. For example, it is length based, right? Based on the number of characters or words, you can split the document. Then there are other techniques also. You can use a recursive character text splitter method. So this is a quite popularly used way to split a big document. So what it does is, based on a given chunk size, let's say you passed a chunk size as 100. Before that, let me show you how we have split our document. Okay. So what I have done, I'm using a character text splitter. That means based on the number of characters, I'll be splitting this document. Okay. So in each chunk, I mentioned that maximum it can contain 500 characters. Okay. So this text splitter is smart enough to split the document such that it maintains the content. It's not like it will it will cover the first 500 characters. Let's say the first 500 characters ends here in this auto no mo. Okay, it's not like it will split. I mean, it will consider this as the first split. No, because it doesn't have any meaning, right? I mean, this half split word doesn't have any meaning. So while splitting, the text splitter is smart enough to preserve the content, right? It will maintain the length of the paragraph. It will maintain the entire paragraph or the entire sentence. Okay. So that's why this is the maximum chunk size. Let me just run this. It will be very easier for you to understand. If you see now what it has done, it has converted this into how many? One, two, and three chunks. Okay, three document section you can see. Now if you see here, this is the first paragraph that it is converted, right? If I print this, it is only 317 words, right? So even if my chunk size is 500, it still kept only 317 words in the first chunk or the first split. So that's how it maintains the semantics of the each split, right? Now if you see, if someone comes and reads this content in this chunk or in this split, the the content itself is self-explanatory, right? It doesn't have any half-baked information or half-cut sentence in it. Okay, that's how the text splitter works. So here I used a chunk, character-based text splitter. There are other type of text splitter also. For example, recursive character text splitter. What it will do, given a chunk size, okay, it will first preserve the semantic meaning of a long paragraph first. Okay, if the long paragraph itself is more than of chunk size 100, then it will try to split. It will try to create split with this complete sentence first it will try with the complete paragraph. If the character length is beyond 100, it will try to create a complete sentence, create a split with a complete sentence. If the sentence itself is too long, it's more than 100 characters, it will then try to create splits with sub sentences which have some semantic meaning. Okay, that's how this text structured based text splitting works. Then there are document structure based. For example, uh, you can have HTML documents, you can load JSON documents, you can load code files also, right? So while splitting this kind of documents, instead of splitting in a character based, for example, if you split a Python code based on a character, right? Character count, it doesn't make sense. The entire meaning of the code will be lost. So in that case, what it will do, the document structure based text splitter are smart enough to let's say split a code file by functions, classes, or logical blocks like if else conditions. And if for HTML file, it can split it using text. So that's how this document structure based text splitting works. So you can try out different methods based on your use case, but here we have use a character text splitter. Okay, so now we see we have total 3 split documents. Our big document is split into 3 parts now. Okay, 3 self-explanatory with parts which has its own meaning, own semantic meaning. Okay, now let's jump to the embedding part. So embedding means converting a textual based data or text based data to a number or a vector, right? You can watch my this video where I have discussed about how to convert text into vectors and different type of methods I have discussed. So why do we do that? Because computers do not understand plain text, right? Everything has to be converted into numbers. So using this embedding model is a it's a trained model with some weights in it, right? Which knows how to convert a text data into a vector or in a sequence of numbers, and vector is nothing but a space in n dimension, right? So I'll suggest you to watch this video. Okay, text to converting text into vectors, that will give you a very practical insights of how to do this. Also, I'll suggest you to watch this video where I've discussed how Spotify recommends songs, right, for you using vector search. So that will give you a practical insights about how vector database works, what is embedding, and how similarity search work. How do we find similar songs, right? How Spotify finds similar songs to the song that currently you are listening to. That's how the vector similarity search works, right? So I'll suggest you to watch those 2 videos first. Then you come back to this video. It will be very beneficial for you because if I discuss those in this video, the video will become lengthy. That's why. So embeddings are nothing but, as I told, it's a model, ML model with some weights, which knows how to convert a text data to a vectors, right? Vector is nothing but a point in an n-dimensional space, right? So that's what embeddings is all about. In our case, we are using OpenAI embeddings, right? We are using the OpenAI model to create vectors, right? Or create list of numbers for our documents, right? We have 3 documents here. For each of them, we will be creating a vector here, okay? Now, if you see, we are importing the OpenAI embeddings model. Okay, this is the embedding models that we are importing. Let's run this. Then we are creating vectors for our split documents. So if you see the split documents we are passing along with the embedding model. Okay, so in this, these are the split documents and we have the embedding models, and this will output us the vectors, list of vectors. Okay, let's say this is document 1, this is document 2, and this is document 3. I've taken a 2-dimensional space for simplicity, but in reality, the embeddings model can create vectors in a multi-dimensional space. Okay, so that's how we have created our vectors first. Okay, you use the embedding model. You now understood about what is embedding, and then comes the vector store. See, when we created these vectors, right? When we created these vectors, let's say this sequence of numbers that we got, this has to be stored somewhere, right? That's where the vector stores come in. Okay, so the job of vector store is not only to store the vectors, but it acts as a database to find the similar vectors, right? As you discussed, let's say user has asked some query and the query has a vector something like this, okay, or something like this. So in order to find the closer documents, right, the similar documents for this user query, we have to search among these 3 other vectors, right? Like which other vectors are closer to this. We can see that this vector is closer to this user query vector. So this kind of search, similarity search algorithms, then indexing the vector documents, then finding a similar other vectors, this kind of things are done by vector store or a vector database. That's why vector store are important. So if you see here, vector stores are frequently used to search over unstructured data such as text, images, and audio. So in our Spotify video, you will be able to understand this in a very detailed manner. Okay, and to retrieve relevant information based on semantic similarity rather than exact keywords. So what is semantic similarity? I'll just give you a brief. Okay, similarity matrix means you can find a similar vectors using cosine similarity, the angle between two vectors. If the angle is small, then the two vectors are similar. Then Euclidean distance, obviously distance between 2 points. If 2 points are closer, right, this point and this point are closer, then these two vectors are similar. And then we have dot product, right? Dot product means we are calculating the projection of one vector into another. If two vectors are parallel, dot product will be 0. The more closer the dot product is closer to 0, then that means the vectors are more similar or more closer, right? So that's what the job of a vector, vector database. So if you see, they have used they vectorized two documents, and here in this case that they have given, they have used in-memory vector store. That means they are using the RAM as the vector store. Okay, just for, this is just for, let's say, learning or POC purpose, not for production obviously. But in our case, we have used another type of in-memory database, a vector database called FAISS. FAISS is a in-memory vector store given by Facebook. So that's what we are using here, and we have created our FAISS vector store from documents. Okay, from documents, using the split docs and the embedding model. So FAISS used this embedding model to create the vectors for us, okay, for the split docs, and then stored in the vector store. This is our vector store that is created. Then comes the retrievers. So retriever, as I told, retriever is nothing but to retrieve and or search on a vector database. Okay, so uh, it is used to fetch relevant documents based on user queries, right? For example, I created a retriever. What it will do, it will just fetch relevant documents from this vector store. Okay, that's what the job of retriever is to. So retriever does the similarity search calculation, then it can retrieve using cosine similarity. It can do so using Euclidean distance method. It can do the similarity search in a different type of ways. Okay, so in our case, we have created the retriever also. Okay, this FAISS provides a retriever for itself. There are other type of vector databases that are not in memory, but production grade vector databases are also there, like ChromaDB and Pinecone. Those are there, and they come with their own retrievers also. Okay, so you can use them. It's retriever is nothing like throwing a select star from this table query. Okay, it's similar to that. You are just reading something from the vector database. That's what retriever is all about. Now, what we have done, we have created, this is where we are invoking the retriever. Okay, so what is the main topic of the document? This is the question that the user is given. Let's say this is the document. Okay, and this is the retriever that I have yeah, that we have initialized it, and I'm invoking that with the user query. So what it will do, I've configured that, give me the top one, or let's say top two matching vectors. I mean, here if you see the top two closest vector to this user query, let's say this is the user query. Okay, so the top two closest vector are this and this, right? So this will give me those documents for a given user query. Okay, now if this is the user query, if I invoke this, you'll see that it has fetched two documents. Okay, okay, I have to run this first. It was configured with one, that's why it generated one. Yeah, now it has generated two documents, which is closer to, out of these three documents it has generated, um, it has found two closed documents which can answer this question. Okay, if you see that the future of AI, this document says great. If I change the question, let me just go through the text file once. The history of AI dates back to mid 20th century. Where does the history of AI dates back to? If I ask this, where does the history of AI dates back to? Okay, if I just to make the search more stricter, right, I'll just pass k as 1 so that we can test if it is able to find a relevant document or not. Now if you see from our understanding, if you see, in order to answer this question, this document is perfect, right, because this contains information about the history of the AI, right, the first document. Now if I just run this, let's see if it is able to fetch that document or not. Okay, yeah, if you clearly see, it was able to fetch the relevant document as this. The history of AI dates back to this, right? The first one. And if we try some other, okay, the future of AI holds promise for solving the humanity, some of humanity's more pressing challenges. What does future of AI holds? Let's ask this question. Okay, what does the future of AI is. Now it should give me the third document, right? Because the third document contains some relevant information to answer this question. If I run this, see, it was correctly able to find a relevant document like this of this, right? The future of AI holds promise for solving some of the humanity's pressing challenges. So that's how we use the retriever to find the most relevant or closest document chunks or splits that can answer, that can be helpful in answering this user query. Okay. So that was about the four or five concepts of today. Okay. Now here what we have done, below what I have done, I've created a chain. Okay, I've created a prompt template. If you can see here, and then I've created. We are using that OpenAI model as the LLM, and then we are using the retriever, right? We are using the retriever here. Okay, to to get uh, to get the relevant documents. Okay, then passing it as the context to this prompt. Okay, I mean these documents that we have got, we are passing this content, this page content as context. Then we are passing the question also, this question also, so that it can answer the user query. Okay, now if I just ask this question here, so this is a chain I have created, and this is the user query, which will be passed to this get answer function, and this get answer function first will retrieve the relevant documents like this, and then invoke the LLM chain. Okay, this is the LLM chain where we are creating the prompt and then asking the LLM to answer the query. So if I run this, object is okay, it was able to give a relevant answer for us, right? If I add something, yeah, so what it did, it used this relevant document, right? Along with it, added its own thought to answer some question, right? If you want, we can add this in your prompt also. It's up to you, like how do you want to customize the final answer, so it will accordingly answer to user questions. So that's how you build a chatbot which can read from external documents. The external documents can be PDF, it can be text, right? It can understand some external documents, and you can then build a Q&A system, question answer system based on those documents. You can upload, let's say, 10 or thousands of research papers or PDFs, right? Or let's say your textbooks. Then you can create a chatbot around it, which can, whatever question you ask, it will be able to go through those books or go through those text data, and it will be able to answer your question. It becomes kind of a virtual assistant for you, right? Which can help you in your research projects, or help you in your studying, in your studying process, right? So that's how these LLMs and these concepts what we discussed today are powerful, okay, to help you design applications like that. So I hope you understood whatever we discussed today in this video. We discussed a lot of concepts actually. Um, we discussed about document loaders, retrieval, text splitters, embedding models, vector stores, retriever, right? So in next section we'll discuss about RAG and agents. Okay. So I hope you whatever we discussed in today's video you understood, and it gave you a practical insights of how to build applications using these powerful components of this framework. So if you have any doubts, put them in the comment section. I'll try to answer them. Okay, as much as possible. So if you like this video, hit the like button in the video and subscribe to my channel. So because we are targeting to reach 2200 subscribers by the end of this month, so keep supporting. So please subscribe, and thank you for watching this video, and I'll see you in the next one. Thank you.